This is homework 7, problem 6. In this problem we're going to graph another exponential function. F of x equals the opposite of 1/2 raised to the x power. Do not forget that negative sign out front. And notice the way I said this, the opposite of 1/2 to the x power. You can see that this problem has a t-chart. What I'm going to show you is how those values were gotten, and we don't even need a calculator to do it. As with the last problem we graphed, we like to use values close to 0, on both sides of 0, for the inputs. And since it's an exponential function, the input is the exponent. So I'll show you how we get the answer when inputting 0 in for x. So we're going to be doing the opposite of 1/2 raised to the 0 power. Order of operations says we raise the 1/2 to a 0 power first, and then we apply the subtraction or opposite symbol last. So 1/2 to the 0 power is 1. Remember that? Anything raised to the 0 power is 1, except 0, of course. And then we apply this opposite, or negative sign. So my input was 0, my output is -1. Alright, let's put in 1 now. Opposite of 1/2 to the first power. Again, I do the exponent first. 1/2 to the first power is just 1/2, and then put the negative sign on it. So 1/2 with the negative sign on it. So I put in 1, and I got out -1/2. Alright, let's put in 2 now. 1/2 squared, but I need the opposite of that. So that's the same as the opposite of 1/2 times itself. You do not need a calculator to do that. 1/2 times 1/2 is 1/4. So the opposite of 1/4. And so my input was 2, and I got out -1/4. Now let's go to the negative numbers. They're a little bit more confusing, but very doable. 1/2 to the -1 power. You learned in the first unit, the first week, that anything raised to a negative exponent, it inverses that number. It flips it upside down, or if it's in the basement, it moves upstairs, or upstairs it moves to the basement. So what that -1 is going to do to the 1/2 in these parentheses is it's going to flip it upside down. So we're going to have the opposite of 2 over 1, but then when it does the inverse, the exponent becomes positive. Well, let's think about this. 2 over 1 is just 2, and that raised to the first power is just 2, but I need to put a negative sign on it now. That's the last thing I do. So my input was -1, and I got out -2. Alright, let's put in a -2. 1/2 to the -2 power. So again, a negative exponent will make you take the inverse of what's being raised to that exponent. So I'm going to have the opposite of 2 over 1, and now the power, or the exponent, goes from a -2 to a +2. Again, the order of operations says I'm going to do this first, the exponent, and then apply the negative sign. So 2 over 1 squared is just 2 squared, which is 4, but then I need the opposite. So I input -2, and I got -4. Now I'm going to plot all these ordered pairs. We have to plan our grid. Let's see. The lowest I need to go for y is -4, and the highest I'm going is -1/4. And my x values are from -1 to, or excuse me, -2 to +2. So let's, I'm going to space out my x-axis a little bit. How about if we make this -1, this -2, this 1, and this 2? Just gives me a little bit more room, spreads things out. And everybody's evenly spaced. There's 2 spaces between every unit. Now on the y-axis, I think I'm going to go, let's see, can I get to 4 in both directions? I guess I only need to get to -4. I'm going to go -1, -2, -3, -4, and I don't need to go up above the x-axis, but I'll number it anyway. Alright, let's start plotting our coordinate pairs. First one is -2, -4. So from 0 to 0, left 2, and down 1, 2, 3, 4. There's -2, -4. The next value is -1, -2. So left 1 and down 2. Then we have 0, negative 1. Don't go left or right, but go down to negative 1. Then 1, negative 1/2. Go right 1 and then down a half. So a half of a space between here and here would be to here. And then finally 2, negative 1/4. So over 2 and down half of a half, right? So halfway in between this space and this space. And then we take our pencil and we connect those points with a nice curve. And we show with arrows on each end that we understand it goes into infinity. And there's your exponential graph of this exponential function.